This is the fourth video, writing formulas for ionic and polyatomic compounds. Here we're going to kind of look at how do you tell the difference? Like, how do you know if in a name and formula, if we're looking at an ionic compound or if we're looking at a polyatomic compound, how can you tell? Well, the first thing, when you look at the names here, potassium chloride all the way down to calcium phosphate, you'll notice that the metals are always coming first. So when you're trying to decide whether or not something is ionic or polyatomic, you don't need to look at the first part of the name, or even when you look at the formulas, you notice that the metals always come first. So you don't look at the first half, you look at the second half of the formula or the name. So chloride, chlorate, sulfide, sulfate, all those names here on the right hand side indicate whether or not it might be ionic or polyatomic. And then the second half, when you're looking at just nonmetals, 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 nonmetals on the right hand side of these formulas, will indicate whether or not it's ionic or polyatomic. All right. One thing that can help you is the back. Here's your periodic table, and on the back of this you've got a variety of charts. Now specifically, if I can get this thing folded up to show you, you got the first chart is going to show you Roman numerals, but then the second chart talks about names for some non-metals. So it actually gives you the formula that you would find on the periodic table with a chemical symbol, and then it gives you the name of the non-metal. Just below that, you've got a chart that's talking about polyatomic ions. So you got the names here, you got the formula, as well as its charge. All right, so you can use those two charts to kind of help you. So if you don't know exactly what chloride or chlorate might be, then check the back of your sheet. Okay, so when you check chloride on the back of your sheet, you'll see, oh, there's chloride. So that is just Cl. If I check chlorate, then, oh, well, chlorate is here. It's a polyatomic ion. So the first one, chloride, we're talking about just an ionic compound. So this is ionic potassium chlorate, though, because chlorate, which is, let's see here, listed right there, it's ClO3, is a polyatomic compound. All right, so this is ionic, and this is polyatomic. Sulfide versus sulfate. So when I look for those names, I see that sulfide is here. It's just S. That's a regular ionic compound. Sulfate, however, which is listed right here, SO4, is a polyatomic thing. So this is ionic compound. This is a polyatomic compound. Again, we can do the same thing for oxide versus hydroxide. Oxide is here, it's just O, but hydroxide, OH, hydroxide is polyatomic. So this is ionic. Lithium hydroxide, however, is polyatomic. Let's look at nitride versus nitrate. Again, look at those charts. Nitride is nitrogen, and then nitrate is, let's see here, nitrate is right there, it's NO3, that's polyatomic. So sodium nitride is ionic, sodium nitrate is polyatomic. Calcium phosphide, let's look for those names. Phosphide versus phosphate. Phosphide, we've actually shown you that in another example. Phosphide is there, that's P. That's just your regular ion. And then phosphate, which is listed right here, is PO4. That is in the chart for polyatomic ions. So phosphide or calcium phosphide is ionic. Calcium phosphate is a polyatomic compounds. In addition to that, what you can look at are formulas as well. If there's just one nonmetal by itself, like here, chlorine, then it's going to be ionic. If, however, there are more than one nonmetal there, like chlorine with oxygen, this is chlorate. This is ionic, this is polyatomic. This has more than one nonmetal, so it has to be polyatomic. Here, sulfur is by itself just one nonmetal, so it's ionic. Sulfate here, though, is SO4, so there's sulfur and oxygen here, so there's more than one nonmetal, so that makes that polyatomic. Same thing here. Oxygen by itself makes it ionic. Oxygen with hydrogen makes it polyatomic. Nitrogen by itself, that's ionic. But we have NO3 here. So we have nitrogen with oxygen, more than one nonmetal there, that makes that polyatomic. Same thing when you look at these examples. Phosphorus by itself, that's ionic, but we've got PO4 here. So we have more than one nonmetal that makes that polyatomic.